Hello, this is part 4 and the final part for practicing with factoring. Okay, so on example 16, we got a factor and we have 8 squared plus 8b plus 2a plus 2b. And what is so special about this? There's exactly 4 terms. So when you see 4 terms, what do you automatically believe you have to do? Grouping by factoring. So split it into half. So on the first half, a squared plus ab, you could factor out a what? Just one a, right? So this is going to be a plus b. And then on the second part, 2a plus 2b, you could take out a 2. That's it, just a 2. So you have a plus b. And then does this work? Yes, it does. Because when you see the repeat, in our case, the repeat is a plus b. If you see that it repeats, that means it works. So you just have to write out the repeat once. Bring down your leftover. So your leftover is a and plus 2. And that's it. This is the most factored it can be. Okay. Okay, let's move on to the next one. 17. Practice factor completely, do not solve. So we have 8p cubed plus 1. So what is so special about this? There's exactly 2 terms and the highest power is 3. So we can't do bottoms up factoring, we can't do simple factoring, we can't do grouping, we can't do quadratic because the power is 3, right? So this so when you have 2 terms, a plus in the middle and a power of 3, you're going to use that one as one of those special rules called the sum of 2 cubes. So the sum of 2 cubes is this rule, a cubed plus b cubed equals 2. A plus b, a squared minus ab plus b squared. Okay, so that's what you're going to do. So if you look at it very carefully, our problem looks like the left side of the rule. So that means we got to make it look like the right. So we got to figure out our a, we got to figure out our b. So what's our a? So this is your a cubed. So your a is going to be a number and a letter. So start with the number. What number when cubed or times itself 3 times gives you 8? That would be 2. And then do the letter. What letter when cubed gives you p cubed? That would be p. Okay. And then b, what is your b value? So what number when cubed gives you 1? 1, right? So once you know your a, once you know your b, just put it exactly like the right side. So it's a plus b, so it's 2p plus 1, and then a squared. If you could just write it out as 2p squared for right now, we'll clean that up later, minus ab, so that's 2p times 1 plus b squared. Okay, and then just clean it up. 2p squared is 4p squared minus 2p times 1, that's negative 2p, plus 1 squared, that's 1. And that's your final answer. Okay, that was 17. Let's move on to 18. Factor example 18, we have P4 minus Q4. So we have to factor completely. So what's so special about this? There's a power 4 and there's a minus, and then there's a power 4. So I think this is no, this is real. I don't think, I know it is related to the perfect square because there's a minus, but instead of a power 4, we have a power 2. So we kind of have to be careful this one. So what is the difference of two cubes? It's this rule. So as you can see, um, our problem is on the left side, and we got to make it look like the right. So what do you think our A value is going to be? So be careful. It's actually going to be p squared because when you square p squared, you get p4, right? So that, yeah, that's why our A value is p squared. And then what is our B value? Our B value is going to be q squared because when you square q squared, you get q4. Okay, so now just make it look like the right. So it's A plus B, so it's going to be p squared plus q squared times p squared minus q squared. Now, can this be factored even more? Because we want it completely factored. Yes, actually, we can factor this. This thing can't be factored, but this thing is also a perfect square, right? So that can be factored out as p plus q times p minus q. Okay. Then over here we have p squared plus q squared. And now this is completely factored. Okay. And let's move on to the next example. Example 19. We have x cubed plus x plus 10, and we got to factor this. So can we do simple factoring? I mean, sure, there's 3 terms, but there's reason why we can't do it because our highest power is 3. In simple factoring or even quadratic formula, your highest power must be 2. So be careful. We cannot do simple factoring. So what can we do? We can't do quadratic because the power has to be 2. So when you can't factor it, the last resort is rational zero theorem and quadratic formula, right? I mean, rational zero theorem and synthetic division. So let's first figure out our possible zeros. So let's first figure out our p. So my p is going to be plus or minus, wait, so our p is 10, and all the factors of 10 are plus or minus 1, 2, 5, and 10, right? And then what's my q? My q is 1. It's usually the coefficient of the highest power. And all the factors of 1 are plus or minus 1. So p over q is going to be plus or minus. So it's just p over q. So that's 1, 2, 5, and 10. Okay. So then we're going to do synthetic. And let's make sure this is in order. So we have a 3. Then it shoots to 1. So we're missing the power 2. And then the constant, right? So we're missing the power 2, so you're going to replace it with 0. So starting with x cubed, the coefficient is 1. X squared has a coefficient, we don't have one, so it's a 0. And then x1 has a coefficient of 1, and then the constant is 10. Since I did this on the calculator, to save time, one of my zeros is -2. Now, remember, there's no trick. You just have to figure out which one gives you a remainder. You just have to literally test one. And if it gives a remainder of 0, that means it's a 0. So put a placeholder under 1. So 1 plus 0 is 1. And then 1 times -2 is -2. And then 0 plus -2 is -2. -2 times -2 is +4. And then 1 plus 4 is 5. And then 5 times -2 is -10. Okay. Now, what about these? So -2 is a 0, so that would be factored out as x plus 2. And then you have 1, -2, and 5, so that's like 1x squared minus 2x plus 5, right? These numbers here is your coefficient. Now, can this thing here be factored, x squared minus 2x plus 5? No, right? It's literally impossible. There's no two numbers that multiply 5, and when added gives you -2. So this means that you have you should have a total of 3 zeros, but 2 of them are what's called imaginary, and that does happen. That does happen time to time. So this is really the most prime, most factored it can be. Good. Okay, last and final one. Number 20, example 20. We have x cubed minus 4x squared minus 3x minus 10. So what's our p and what's our q? So my p is actually 10, and all the factors of 10 are plus or minus 1, 2, 5, and 10, right? And then what's my q? My q is going to be 1, and all the factors of 1 are plus or minus 1. So p over q is going to be plus or minus 1 over 1 is 1, 2 over 1 is 2. Wait, so 1 over 1 is 1, 2 over 1 is 2, 5 over 1 is 5, 10 over 1 is 10. We're going to do synthetic, and what zero shall we use? Our zeros would be 5. Let's try 5. And then check if it's in order. 3, 2, 1, constant. Everything is in order. So this is 1, -4, -3, -10. Put a placeholder under 1, so 1 plus 0 is 1. 1 times 1, 1 times 5 is 5. -4 plus 5 is 1. 1 times 5 is 5. -3 plus 5 is 2. 2 times 5 is 10, so it is a remainder. So if 5 is a solution, factor form it would be x minus 5. And then these 1, 1, 2 is your new coefficient, so that's 1x squared plus 1x plus 2. Now, can this part be factored? No, right? There's no two numbers that multiply 2, and when added gives you 1. It's literally impossible. So what that means is you have 2 zeros and 1 real 0. So this is your final answer. This is the most factored it can be. Okay. That's pretty much it. Yeah, for this section.